When I was asked to put this together, I had an epiphany, and I said, man, my whole career has really boiled down to watching paint dry, so. All right, so it's more than just paint, and this is some of our successes, our failures, and lessons that we learned the hard way. So a little bit about myself. My name's Jonathan Moore, West Virginia University graduate, supervising engineer in the bridge maintenance and construction section here at DelDOT. And I've been with the department going on 8 years. I handle the maintenance and construction activities in our two lower maintenance districts, Kent and Sussex. So, moving on. So Delaware is a pretty small state, as you guys know. We have 1,782 bridges, but we have a lot of paint. 366 of those bridges have some sort of steel painted element, which equates to 11.6 million square feet of steel coatings. And we have 193 bridges that have some sort of concrete paint on them, and that number is constantly going up. In the next 10 to 12 years, we anticipate needing to coat at least 4.8 million square feet of steel superstructures, and that's just over our interstates alone. So that's not accounting for a lot of the like the back roads and stuff that we have here. Delaware is an interesting state. We have cities like you're in right now, and then if you go down south, you wouldn't even think that you're in the same place. It's just a bunch of cornfields. So yeah, so a lot of paint coming up too. And this whole topic basically spurred off of what I would consider a pretty big failure. We've been producing paint contracts for years now. This one started off just like all the rest. It was no different. It was a 12-structure contract, and in the end, only 8 of those structures ended up being completed. We had multiple issues pertaining to the whole contract. A lot focused around our air monitoring requirements. Our containments were not containing. There was blast operations where you could see visible emissions, cars getting coated on the highways. It was a complete mess. So the one thing that all of these issues kind of just kept pointing back to was some pretty serious loopholes in our specification, and it kind of left us all scratching our heads like, what can we do to avoid this ever happening again? So these pictures might be a little bit hard to see, so you might have to take my word for it, but I got some little arrows pointing this out. One of the first issues was some really heavy application of the coatings, which was actually causing the coating to sag. And as you can imagine, if the coating's own weight is pulling it away from the base, you're not getting good adhesion. And this one, also extremely hard to see, but these are little tiny blisters. And what these blisters are is when your coatings are curing, they go through a process called outgassing. And the coatings were so thick that the outgassing was not happening at a proper rate, and it was causing these blisters to form in your top coat. And these were throughout the entirety of the structures that we had coated. And here's another picture of these blisters, and when those blisters would pop, you would always find a uncured mid-coat or even down to the zinc primer, which was still wet to the touch 10 days after application. So we took a sample, had it sent to a lab, and the lab showed that our coating system was over 300% too thick. And as you can see, all those little holes in the porosity in the coatings, that's your gas trapped. And it was so thick that it couldn't escape, and that's what's causing those blisters. So adhesion was a concern and an issue, and this was kind of the straw that broke the camel's back, so to speak, and this is what made us say, hey, let's scrap the last 4 bridges on this contract. This is just not working out. So with that, we had to change the way we think. Teaching old dogs new tricks. For years, the mindset has been, paint is paint. Go out there, paint the bridge. What's the big deal? The contractors that we used to work with, they had a lot more freedom. Our construction inspectors or the people that would work for the department were not necessarily certified in paint per se. They would just be a guy that would go out there and mark the amount of quantity that was done that day and keep track of, what equipment they used, who was there kind of thing. Not necessarily keeping track of the application, products used, things like that. So there was a lot less supervision back then. We lacked certified coatings inspectors. There was tons of loopholes in the specification, and ultimately that led us to a complete and total spec rewrite. With that, we formed a task group with GPI and their coding experts, and we rewrote our spec entirely. So the big thing that I really want to stress to you guys is that your specification is key. Having a good spec is, the end-all be-all to, how well your contract is going to end up going. Our original spec, the old spec that I came in with, dated 2016, but it hadn't been revised since 2001, really. It was riddled with loopholes, and one of the main loopholes that I'll use as an example is we have a lot of requirements for air monitoring, for testing and disposal, and all of those requirements kept pointing back to lead. It just kept saying lead, for bridges with lead. But in reality, there's 8 or so toxic metals that you can find when you're blasting or painting a bridge, and we should be, looking out for all of those, not just lead. We also had a ton of ambiguity in our requirements. The specs lacked specific direction, and it really opened up the door for a lot of open interpretation from the contractor. We referenced tons of old or outdated resource material. The equipment that we were referencing and the tools that we referenced for our inspectors were extremely dated. And a big thing, in my opinion, was we lacked hold points for our inspectors. So basically, if the inspector saw something that wasn't going right and they told the contractor to stop, the contractor could tell them no because our specification didn't make them stop. So, the new and improved one. This one, as I said, myself and a team with GPI and some other people that work at DelDOT sat down and we rewrote the spec entirely. This new spec, the key takeaways from it would be it's definitely more directive now, and we have our hold points, which are a big plus for our inspectors, and we've updated all of the reference manuals, all of the different, the different resources and tools that we would reference in there have all been updated and brought up to the industry standards. And we've also established more personal qualifications for our contractors. So, success, sure, we're getting there. The mindset of the department has definitely changed, and we're now thinking of these as coating systems and not just paint. The designers are taking it more seriously. The inspectors are taking it more seriously. And in response to this, we've held a training course that we had GPI put on for us. And it basically gave all of our engineers that mile-high view of how to incorporate a good coating system on your bridge. And it was received with great accolades from everybody, and they basically said, I never thought of it, as paint being so complex. I never thought of it as being, so intricate. And I said, yeah, me neither did I until I, got thrown into it. So now the inspectors, they have the tools and the support in the spec to efficiently and effectively oversee each job. And ultimately, I think we're getting a better overall product because we're using better practices. We're adhering to updated reference manuals, using better products, and we have, more strict parameters listed out in our spec. So the contractors, have better guidance as to give us what we want. So here are a few pictures of just the overall quality that we're now seeing. On the left here is a really nice example of what I would consider to be a perfect blast. That steel is very clean. The middle photo there shows a really nice job for a stripe coat application, and the far right photo there shows top coat, and it's just a uniform sheen, very even application. All the film thicknesses we're reading very uniform there, and it shows in the final product. And so basically we are really happy with how things are going now. We're going to continue to make changes as we need, and we'll update as the AMP and SSPC and NEPCOAT standards change, and also the department has taken interest in that, and they're sending me to get my bridge coating inspector level 1 course actually next week, and hopefully that's going to be a trend that we see with more engineers and designers in the department going for that as well.